Hello and welcome to the fourth and final part of our presentation about the Southwark Bridge Layout. In this part we will be looking at the layout development, how it is put together, various recent projects that we have undertaken, and how we are using technology to build models today. As noted in part 1 of the presentation, the Southwark Bridge Layout has been around for a very long time, since 1995. The baseboard construction is of its time. Very heavy, made from timber framing, covered with a chipboard surface, resting on a metal underframe. Even with this heavy construction, we still find it moves due to variations in humidity, and the layout does seem to run better in the summer rather than the winter. The electrical system is very much 1980s technology. Traction power is analog with traditional wiring. For the main traction power bus bars along the layout, the wiring has been duplicated to mitigate for voltage drop, given that the layout is 45 feet long. Fortunately, the locos are fitted with coreless motors, so draw relatively little current, which is why we can run up to 6 engines coupled together from 9 elms. The wiring is fully documented, although in some areas it can be a bit sketchy. Track power switching is automated and linked to point setting and signalling. The relays are controlled by the interlocking program running on the Raspberry Pi. The point machines have reed switches, which are changed by a magnet that moves over them. The switches are used to change polarity of crossings and to give detection for the interlocking. The point machines are homemade, with a motor winding the mechanism backwards and forwards, depending on the signal lever setting. The grey magnet moves over the reed switches, and the rods at the bottom operate the turnout switch blades. And it is all neatly hidden away under the loco yard, which is mounted on a slide-out tray. Now we get to the ugly underbelly of the layout. In essence, the control system is built using 1980s electronics, things like logic gate chips, and lots of contacts and relays. This is probably the Achilles heel of the whole layout, as it is quite fragile and would not tolerate being taken to an exhibition. The interlocking is controlled by a computer program. Up until a few years ago, this ran on a Commodore 64 computer. Remember those? The program samples the state of the points and signal levers, checks that the combinations are valid, and if not, gives an alarm. It repeats this process every 1/10 of a second. Here is the original computer and an extract of logic documentation for the program. The Commodore 64 was only a little computer and required strict memory allocation to make everything fit in. The program itself was written in assembler. There is an extract on the right. The situation was completely unsustainable as the Commodore was obsolete, and if it failed, then the layout would be dead. We looked around at the then available technology and found the Raspberry Pi, about twice the size of a credit card. A remarkable little machine that could run programs written in high-level languages such as C, and after testing we found it was easily fast enough to run our interlocking. First we had to analyze the interface between the existing computer and the layout. The technology in the interface board uses a multiplexer approach. We built a breakout cable and then recorded the messages that passed backwards and forwards between the computer and the interface boards. This is a sample of what we captured. Based on this information, we developed a program to mimic the one on the Commodore 64. This was written in C so that it can be easily ported to a new computer if required at some time in the future. Let's now look at how the scenery has been put together. First thing to note is that there is no grass anywhere on this layout, which probably makes it unique. It's all about grimy buildings, all soot covered, and the urban environment. A range of techniques have been used to make the scenery, and these have evolved over the 25 years of building the layout, including wood, paper, card, plastic art, laser cutting, etching, and more recently 3D printing. In many cases, the items of scenery, be they buildings or vehicles, are based on real examples. In the first part of the presentation, we talked about the buildings and how they were put together. For example, the loco shed is modelled using wood, paper, laser cutting and etched windows. The station canopy was made using etches. And now we've started to look at the station frontage. The drawing has been produced, but we have yet to start modelling. It is likely that this will be made using 3D printing. The pubs and street scene buildings are modelled using brick embossed plasticard. And the terrace. The railings use some leftover etches. The carcass of the model is foam board. The viaduct sides are made from etched brass sheet and then decorated using Humbrol stone colour, followed by Caran crayon to give the variation in brick colour. The Thameslink viaduct is covered in brick embossed plasticard and topped with a 3D printed parapet wall with dentils. The bridge deck was described in part 1. It is 3D printed detail around a metal carcass. Now let's move on to looking at some of the more detail items that we have produced. We need a fleet of taxis to populate the station taxi rank and the layout in general. Here we see one of our prototypes, a 1911 Unic taxi at Bewley Motor Museum, who kindly allowed us to measure this vehicle as part of our research. We captured key dimensions and took loads of photographs, and based on this Mike Day produced this drawing. We then produced a 3D CAD model for the taxi and then broke this down into a fret for production in the 3D printer. The idea being to get flat surfaces upward facing to produce the best quality print, thus avoiding build lines in vertical faces. We also printed models for the driver in 3 different poses. And here is the final assembled model. In addition, we made a model for a Renault Taxi Type AG 1905. They are the blue ones in this lineup. Now let's take a look at one of the new buildings that we have made. We needed something impressive for the street scene that stood in stark contrast to the terraces. This is the Homewood building at 97 Southwark Street, and it was ideal for our purposes. Alistair Lindsay, a member of the group, undertook a photo survey of the building as it is today. As you can see, there is lots of complex brickwork to make, and each level of the windows is different. As part of our research, we found this floor plan. It would appear that the building was erected for use as accommodation by the fire brigade, but more recently has been converted to flats. The peculiar wedge shape is due to the original medieval street plan in this area being orthogonal, and modern Southwark Street being cut through at an angle, leaving some odd-shaped plots at intersections. The thin narrow shape suited our layout nicely. Based on Alistair's photos, Mike Day produced this drawing showing the front face and an enlargement of the ground floor windows. To check the context in relation to the rest of the layout, we produced a simple cardboard replica. This shows the height relationship between the street below and the railway on the viaduct. Our proposed building would give the feel of the train moving in and out of view between buildings as it progressed. Based on Mike's drawings and Alistair's photographs, we produced a CAD drawing and 3D model for the frontage. The model was then broken down into components for manufacturing purposes. The joints in the fascia brickwork were positioned above the windows, minimizing the blending in work required between different sections of brickwork. All the components are assembled into a tray ready for 3D printing. On the left are sections of brick frontage. Then moving across, there are the top coping sections. Then we have the components for the windows. In the corners there are a couple of views of test sections that we built to ensure accuracy of fit and ease of assembly. The printed sections were then glued to a wooden carcass to make up the whole building. And here is the finished building frontage after decoration with Caran crayons for the brickwork. The original building has a curved end, with brickwork arranged as headers following around the curve. We reproduced this in our model by printing the 3D brickwork flat, and then gently forming it into a curve by heating it with a hairdryer on low temperature. This is a cruel enlargement, but it does show nicely the header brickwork and the cornice detail. And here is the original. Not a bad match. Finally, we will take a quick look at the gasworks. This is only an overview, and a more in-depth presentation is available called Phoenix Gasworks, which gives much more information about the research carried out and how the model was built. We wanted to give the impression of a cramped site with everything squeezed in, whilst at the same time making sure that we represented the gasworks accurately. Building the gasworks required research into the various items of industrial equipment and then producing typical models for each of them. So please view the video for the Phoenix Gasworks and find out more about Sir George Livesey, possibly Southwark's greatest son. Here is a statue to him. That completes our visit to Southwark Bridge. On reflection, what were the good bits? Well, the layout still works after 25 years, a remarkable achievement. It's fully operational, and we're still adding rolling stock and scenery. Then there is the research interest. It has driven us to find out about all sorts of industrial archaeology, in particular connected with the gasworks. The layout has proved to be flexible for updates, for example the new interlocking. And very good equipment choices were made for the locos. Porter-Scat motors and compensation make for reliable running. And it consistently entertains and challenges 12 to 15 people at our bi-monthly operating sessions. Also on reflection, what will be changed? Better planning, in particular the layout of the scenery. The baseboards, these will be made of metal to be much lighter and to give stability. Then it would have been possible to take this layout to Scaleforum. And the wiring, enough said. That concludes our presentation about Southwark Bridge. If you're interested to find out more detail about the Phoenix Gasworks, please view that video. Thank you for watching, and both Mike Day and I, Ted Stevens, hope that you found this of interest.